Welcome to this fanPol tutorial. My name is Phil, and today I will show you how to use fanPol to process your laboratory fan performance data. You will see that fanPol is a powerful tool that quickly assesses the quality of your lab data and to create and extract performance data that was not measured in your original lab setup. Let's say that you have tested a fan in your lab where you have acquired basic performance data like the volume flow, the static pressure, and the required shaft power. You did that for a number of operating points, and you have altered the blade pitch angle or the RPM. You might have even tested several modified versions of your fan in the same way. The data is stored in an Excel file like this, with separate spreadsheet for each fan version, and every spreadsheet has a table with columns representing the measured performance data. A common task is to compute the untested performance data, which could be the static and total fan efficiency or AMCA's new fan energy index. fanPol makes it very easy to process your data. On the left-hand side of fanPol's user interface, you'll find what we call the data navigation tool. That's where fanPol stores your input data in fanPol's basic version, and where you can set up interpolations, performance contour plots, and scale fan sizes and fan RPM in fanPol's Pro version. Just right-click on Input Data and select Add New File. In the middle of the screen, you can now find the Input Data option tool. That is where you tell fanPol in which format your data is stored and what kind of fan data you would like to process. First, open the Excel sheet that contains your data. Name your experimental data. Then, tell fanPol if you want to process your fan with variable blade pitches or variable RPM. Pick if your measurement data is in imperial or metric units. Finally, select which spreadsheets from the document should be imported. Now, please click on the Data tab. Here, you will tell fanPol where in your spreadsheet the measurement data is to be found. You don't need to input a full set of performance data. If a few mandatory fields are given, fanPol will compute the remaining data. Such mandatory fields are the volume flow, either of the pressures, and power or either of the efficiencies. In our example, we measured the volume flow in column B, the static pressure in column C, and the shaft power in column D. The blade pitch angle is saved in column A. We will set up fanPol accordingly. Finally, we need to provide fanPol with a few characteristics of the fan. Please click on the Fan and Motor tab. We will need to fill in the outlet size of the tested fan. In our case, it's a 42-inch fan. Set the motor properties if needed and choose the right fan type. In our case, we measured an inline axial fan with free inlet and ducted outlet. We can set up everything and you can click on Import Data. In the Data Navigation tool, you can see a little plus appearing next to the input data. You can click on it and see our imported experiment. If you click on the plus next to the experiment, you can see 2 data sets were imported. You can even open those to see the different blade pitches and the operating points for each blade pitch. If you click on an imported data set, the Data Property panel appears in the middle of the screen. In the data table, you can see all imported and computed data points. On the right-hand side of the screen, you find a plot of the data points. You can use the navigation panel in order to scan through the data. If you find points that are obviously measurement errors, you can right-click on them in the Data Navigation tool and remove them from the dataset. If you navigate to Efficiency, you'll see useful information about the fan efficiency. There, you also find the new fan energy index that instantaneously tells you how energy efficient a fan is compared to a baseline fan defined by AMCA. If you want to know more about the new metric, feel free to check AMCA's website and check for Standard 208. You can now save your computed performance data to an Excel spreadsheet by right-clicking the fan or experiment in the Data Navigation tool and choosing Export Data. Please insert a file name and click on Save. fanPol exports your data to an Excel spreadsheet. You can find the full set of performance data and all the blade pitches and points. You can now use this data for your fan selector or to post-process it further. Those are fanPol's basic functions. We hope that you enjoy fanPol. If you're interested in fanPol's advanced features like RPM and blade pitch interpolation, scaled fan sizes and fan speeds, and fan performance contours, check out our website on fanpol-software.com.